Welcome, everyone. I'm Margaret Pizzola-Granlund. I'm the director of the Art Gallery at the College of New Jersey and also the Sarnoff collection at the College of New Jersey. And I know you're all here for the Sarnoff collection and our monthly Sundays at the Sarnoff's program. I'm going to introduce our speaker. We're very fortunate to have Jesson here with us today. He's been a great supporter of the Sarnoff collection. He's a great fan of the Sarnoff collection, I think, and we're really looking forward to his talk today. The talk is titled Unsung, World War II Codebreakers and Y Operator Heroines of Bletchley Park. I can tell you a little bit about Joe. He's currently president and chief technology officer of RF Signet Group, a wireless and patent consulting company in Hamilton Square, New Jersey. Joe has over 35 years of experience in engineering and technology management at Motorola, CNA, Oak, and Amoco BP in Chicago, and is co-founder of Asset Intelligence, a General Electric corporation. He was awarded the General Electric Innovation Prize, the Edison Prize, in 2007. Joe is currently adjunct ECE professor at the College of New Jersey and is IEEE Princeton Life Chair. Joe was awarded over 15 patents and holds graduate degrees from DePaul University in Chicago. And as you'll learn today, he has a great interest in the history of technology as well. So help me welcome Joseph. I'm sure you're all clapping at home. I'm sorry we can't be at the Sarnoff to do this in person, but we're happy to have you online.
Yeah, it's a shame we don't have to be here. We can't be here at Sarnoff in person because they're the best, they're the greatest. And this talk today actually comes from most of the research I've been doing in the area of the my approach from the technology perspective in Sarnoff is I discovered that the preferred interception receiver at the throughout Great Britain and was during World War II was designed and manufactured by RCA in Camden. So that was what really piqued my interest, and I talked Margaret into procuring a AR-88 interception receiver that was designed and built. It was actually built initially in prototyped and built in Camden, and then it literally went throughout the world as the preferred interception equipment throughout World War II. And that included not just the UK, but our allies, our Russian allies. They were also extended these receivers, these interception receivers throughout not only Great Britain, like I say, but on the Lend-Lease deal, Lend-Lease deal. So the Lend-Lease deal was a program that was started in order to get equipment as quickly as possible in the hands of Great Britain and the USSR at the time. And then basically they were loaners and they were supposed to return it. And at the end it was, they were told to destroy the equipment, or, you know, it ended up getting recycled in a lot of personal collections that went out. And but the receiver itself was designed and ordered the design by at RCA by David Sarnoff himself. He was a great patriot and wanted to do whatever he could do to help the World War II efforts. And David Sarnoff was basically given several awards for his participation. From a researcher perspective, the easy part was understanding the hardware, because my language of choice is schematics. So I could look at the schematic of the receiver, and then now that we have a receiver that was rebuilt kindly by Jonathan Allen, which we give him kudos here, shout out here. He might be on, hopefully it's on. But Jonathan Allen took unit that came out of a farm, a barn on a farm, literally, that was corroded and brought back to life. So you can, when the Sarnoff is back open again, you can get a chance to look at that. And Jonathan did get it operational. But my original research came from studying the receiver design and why it became the favorite and so forth. But in that research, I found out there was an incredible effort to crack the German Reich codes and the ENIGMA encrypted codes. And I got to get into the details on that. And I ended up getting quite a few books. The books, there's a general secrecy vow you have to take if you work at Bletchley Park or you get recruited to work on this energy or enemy decryption. And so if I said at the top of the slide here, if you look at the German domination a la 1942, all the bright red was under German Reich and occupied territories. So Churchill had a goal of Winston Churchill was the one that drove this project, and his goal was to intercept, decrypt, and secretly distribute enemy communication. Now, so there's lots of issues, not just the least of which is decryption, but we're going to get into my next slide talks a little bit about the challenge. So this is a huge challenge, right? So we want to intercept all the enemy's communication. And because in that encrypted communication is, of course, all their logistics and deployment, and had to keep it secret. But let me just talk about what. So the goal here was to build a staff required to intercept, and then ultimately, intercept, encrypt, and distribute. Now, the military took care of the distribution because they were under direct signatories. And director, like I say, Churchill directly controlled the distribution list on this, because at any cost, this could not fall in the hands of the enemy. Because if the enemy knew, if the German Reich knew that we were reading their logistics, communication, and troop deployment information, it's a game changer. And Winston Churchill called this particular project that he managed his golden goose that kept laying golden eggs that did not crack. So his last comment about that did not crack was the reference to the Secrecy Act in Great Britain, which is, you sign this, you sign an agreement for, I have documented in one book where a woman that had worked on it in her 90s in 2012 that talks about that the Secrecy Act is for over 30 years. Now, I was curious, she said over 30 years, and that was kind of supported by the some of the punishment that the government, U.S. government did, believe it or not, with we're going to get into that, with one of the unsung heroes who wrote a book about it. And it was only 25 years when he wrote the book. And they said, you broke your Secrecy Act, So even today, many of the books I have are relatively new. And the one book I'm going to refer to, there's one passage here that's interesting about recruiting that I'm going to refer to that was just published in 2012. So here it is, all many years since the end of World War II, we've got new books coming out on the war effort because people were serious about taking the oath of secrecy. So one of the first problems is if you're trying to solve the problem of reading the enemy's traffic and communication, you have to build a staff that is competent to do this. And interestingly enough, because of the war, World War II was an existential experience for Great Britain as it was for our country, more so Great Britain. It wasn't clear that Great Britain was going to win the war, World War II. So, and certainly before the U.S. jumped in, there was some real concerns, and Churchill's rise to leadership was fraught with many people fighting him on going to war with the German. So here's an example of Marjorie Pullen. So in roughly 1941, her friend Joy, I spelled that Joy, Marjorie was one of thousands employed at Y-intercept stations, and I'll talk about that in a minute, whose job was it to harvest raw material. That's what they mean here is, and I'm quoting this is communication material. This is intercepted traffic for the code breakers. So here was the resume, an ideal resume. Now, if you look at some of these requirements, so the first thing they looked for was enthusiastic. You know, somebody has to have high energy. And really, if it's going to cost you your life and your country, you know, you had very enthusiastic people trying to win the war. And as and many of you probably saw the Imitation Game, the movie with the focus on Alan Turing. Well, Alan Turing is a brilliant mathematician, number one, but one of the key guys used for is but what I'm going to talk about is, well, one of the things interesting that I found it. First question I have, and I'm not a historian, but the first question I had is, where did brilliant Alan Turing go for help? So I kind of followed that path, and I found out. Well, we'll get into who he turned to for help, but there's more interesting material on that. So anyhow, the ideal resume, if you come, and in this case, they conscripted women, and some went in military, of course. And this is an example down here of Marjorie Pullen and her friend Joy. So she was conscripted. She was given a choice, but they mapped her knowledge against their resume at the time, or their interview process. So the ideal person would be a puzzle solver, advanced mathematics background, German speaking, fluent in speaking and writing German, and fluent Morse code operator, meaning you had to at least copy and read greater than or equal to 25 words per minute in Morse code. So as you can see, this is a real killer in terms of a resume, and I need to add, there's long hours of working alone in this, and this isn't a occasion to go, even though many of these assignments were sent overseas from the UK and going throughout the world to get close to the transmitters. Mobile transmitters, you had to be fairly close. So if you're monitoring General Rommel's troops in Northern Africa, you really need an office, and I think they picked Cairo where they sent. And most of the people that if they didn't fit in the ideal resume, if you had, let's say, I think, I haven't studied this, but if you have 3 or 4 out of this list, you got the job. And what they did when they ran out of people that understood Morse code, which at that time before the war, you were an amateur radio operator if you understood Morse code, especially if you have your license and you could handle greater than 25 words a minute. Anyhow, those people were snatched up right away and hired, and in some cases conscripted to immediately go to work. And in other cases, when they finally ran out of Morse code operators, they would have training, on-site training, and that would get either military or someone who signed up willingly on the up to speed on the Morse code. The German wasn't an absolute requirement, but people were hired on the spot and promoted on the spot if they could speak and write Morse code and willing to learn. German, and willing to learn high-speed Morse code. So anyhow, I just thought that was interesting, what they were looking for. Now, they quickly ran out of people that met this ideal resume. they probably, I don't know what the total, well, I know that the total numbers were. So there was a total number of between 10 and 12,000 people that worked on this. And that included Bletchley Park employees and other people like interception operators and other locations. There was a total of roughly 10 to 12,000 people. And it's documented that out of the 10 to 12,000 people, 8,000 were female. So I thought that was one of these things like, wow, we should know these kind of facts, You should talk about history. This is the way to learn history. So I grabbed a shot, and I haven't taken my earlier banner off of the AR-88 interception RCA receiver, but this is an example. The woman on the left is a Y, considered a Y operator. Now, Y just stands for, it's abbreviation of wireless, or WI, they call them for shorthand Y operators. So this woman on the left is beyond the resume, when you realize what her work has to be. So she has to look at that worldwide map, and you have to realize she's assigned a certain band of frequencies and a certain area of the world. And you could see that she's sitting in an underground tunnel. Now, one of the reasons why most of the Y operators were hidden, and is because a large antenna is a dead giveaway for German Luftwaffe pilots. If they see a large antenna and it was attached to Bletchley Park, they would take out Bletchley Park with a incendiary bomb. And so they had to move all the antennas and distribute those off the Bletchley Park campus. And so many, if not most of the code crackers, decryption experts were in various huts. So these were buildings, temporary buildings set up on Bletchley Park's campus. So they had teams of code crackers defined by their hut and other activities that were going on depending on what hut you were in. And I have, in fact, there's one of the more interesting books is called the Hut 6 book. So this was written by Gordon Welchman. It cost him his job. It cost him his clearance in the at that time as a predecessor to the NSA, where he was working at MIT. He built the first computer at MIT after he left the war effort. But more on him later. But so this gives you some idea why a lot of the Y operators were in outposts. And if you were sitting in Cairo, you were in the basement of some small building, and your job, you're working over 7 hours a day, listening to Morse code. And then so that's part of the job. Let me just talk a little bit about, and I'll come back to this, but the way communication occurred in German military. And here's an example of roughly May 1940, General Heinz Gordon in a half-track vehicle. So in order to send messages to Berlin or wherever his command post is, where he gets his orders from. So Heinz basically had 3 communication operators that just were nothing more than getting messages back and forth between the field. If he's in the field, he's communicating back at headquarters. So you have if you go to the guy all the way to the right, he's the message form operator. So he has the message that General Heinz put together in German. Then he hands that message to the person on his right, which is an ENIGMA encryption operator. So what the ENIGMA is, and we're not going to do too much about the ENIGMA. That's about a 2-hour talk. But the way the ENIGMA worked, it was a secure communication system developed and sold out of Switzerland. It was a commercial product before the war, and then it moved into a primary means of communication in Nazi Germany. So the ENIGMA was actually he would take the message from the message form operator, and then the Enigma encryption operator would set these little wheels that would be the encryption key, which changed frequently. And it's specifically, they were referring in this photograph to a 3-rotor Enigma machine. So you had little wheels and disks that had to be sent for the code of the day. And the Enigma operator then would set this message and then type the message, and out would spit out an encrypted message from the message form operator. So now the message encryption looks like a group of 5 alpha characters. So you might see the output doesn't look at all like German. It doesn't look at all like English or any known languages. So you have groups of 5 alpha characters that comes out of the Enigma encryption machine. So then that operator takes the 5 alpha key array and then hands that, prints that out or shows it to the, I believe he prints it out. Yeah, there's a pile of paper in front of the radio operator. So now the radio operator transmits those encrypted alpha groupings into Morse code. So he or she is an encrypted Morse code operator that actually takes the message and sends it over the air. So this goes over the air from the radio message operator, an encrypted message. So you see the layers here. Now you got some serious. So now you realize the interception operator has to unwrap this, and I'll show you how far. So this is an example of a Rent's encryption machine at 12 rotors, and the possible number of start positions, which is sets the key, is 1.6 billion possible position. So the German High Command knew it was secure. There's no question about the machine being secure, but they made some mistakes, and the mistakes really cost them, I think, the war, if you look at it. So in the beginning, it wasn't the British that deciphered Enigma or cracked the Enigma code. It was 3 Polish mathematicians, and Marian Rajewski, Jerzy Rosiecki, I'm going to butcher this, Rosiecki, and Henryk Zagalski. There were 3 in December of 1932, they cracked the Enigma code. And then they basically had meetings, in-person meetings, where they showed the British encryption experts, a few of their leaders. Dilly was one guy, Wilworth. But what they did is then the Polish showed the British how to get started. Now I say how to get started because either the Germans got a clue that they deciphered the Enigma, or they just decided to harden the code and they changed it. So they extended the number of wheels that would render the Polish deciphering technique not useless, but it wouldn't directly decrypt the Enigma code machines. I mean, the messages decoding machines. So let's go back to what's a Y operator. So here's a Y station. So a Y station contains multiple interception equipment, and this is a fairly large one. And you see the actual radios used, the receivers used were built by RCA, designed and built by RCA, and they are AR-88s. It wasn't the only type of equipment, but that was preferred, and I'll get into why it was preferred in a minute. But this was a typical station. This is actually a large station, and right next to that it's an outpost, so you can have things like these antennas. So as I said, you cannot be right on Bletchley Park. But here's an example of an antenna. They call it an aerial array, some of which had a span of 1,000 feet. And this was part of this Y station and in Kent. And they pick sites that they can, ideally, if they can get an altitude where at least the antenna's at an altitude in a free form area, that's ideal. So the Y station interceptor operator is typically was put into a 4 to 7 month training program. So this is a classroom that they had. So you had basically extensive Morse code training. As I said, you had to get to a very high rate of Morse code, and you had live equipment in this room. And so this is one of my favorite books, by the way. This is the 2012 book that I was quoting from. So this is what they had as an intensive training program, because again, they couldn't get thousands and thousands of intercept operators trained in Morse code unless they had specialized education. And this is the output. So this is what you got from a Y operator. And here's where it gets interesting. So you see in the so there's H King was a Y operator, and it's got the time, the date at the top if you look over. So this is 1941, 12th month, 9th day. And the time of day is on the right. If you look at the left columns, there's the dial readings. Now, dial readings on the AR-88 were calibrated, so they took it generally from the dial itself. So the KCS, that's your kilocycles. RST is your description of your signal strength and your quality of signal. So 438 describes the quality of the signal that's received. And then you move over, and then the call sign. So every operator has in clear text the call sign that begins the message. And by the way, they used to end with Heil Hitler, which is a big no-no in encryption. If you mix plain text in with messages like the weather, they made that mistake, and Heil Hitler signature, that was not good, because for them, it was great for the encryption operators, because then they could determine what the code word was if they can go back, and it shortens their search space. But okay, so then they actually write down, so the in the body of the text on the right, you see AOHLC, and right next to that, underneath that, is XFGEL. Well, that's your output of your Enigma machine being sent through Morse code. Now, very difficult to do. Number one, the frequency described is called HF, or high frequency, and it's 5400 kilohertz. Has conditions that there's good band conditions and there's bad band conditions. There's fading that occurs. So propagation of this is not very good. So the Y operator has to be really, really talented of listening in through the noise when they can barely hear. Let me give you an example. When you can barely hear the code, dots and dashes coming through, which comes in as tones, you have to be careful to make sure it's optimized from a filter perspective. And also, if you narrow the bandwidth, you'll get better signal to noise and so forth with Morse code. But if you look at their notes, they have VY heavy atmospherics in the body of the text. So what they're saying at this particular location, QTC, it says very heavy atmospheric. So if there's lightning storms in the area, it raises hell with at 5400 kilocycles. Today we call them kilohertz, in honor of Heinrich Hertz. But this is what comes out of the intercept operator. So the interceptor operator can be sitting on the other side of the world, and if they have the right antennas, and so you had intercept operators scattered throughout the world. Again, if this was a very low power transmitter, which they were in the field, you had another problem too. These transmitters in the field would drift. So the operator, the operator, you think the hard part is just writing down listening to Morse code and writing down AOH, LC, blah, 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 writing all this stuff down over 7 hours a day. It got more interesting because the transmitter didn't stay in one place. So if she marked 5,400 kilohertz, at certain point, it drifts. And the AR88 was one of the specs that were written was to minimize the drift on the AR88, because you don't want the Nazi transmitter drifting and your receiver drifting. And I mean, it's hard enough on the Y operator, but here's where it gets really interesting. So the Y operator has to compensate for signals being lost in this case, heavy atmospherics or noise, lightning noise, impulse noise, but they actually had to track drifting transmitters, and they had to compensate for fading, atmospheric fading, and the very good ones that would have been out for a while were able to identify the operator. Now, I ask you, in AI today, they're just basically touching this area of automatic modulation, interpretation, and decoding, just from the modulation and just from the signature, just from the way the Morse code is sent. So that's kind of stunning. Oh, by the way, I think you're welcome to ask questions during this presentation if you want. I think we wanted to keep it open, didn't we, Margaret?
Yeah, I'm monitoring the chat. You can either type questions in the chat or you can type them in the Q&A, and we'll get to them as we go along.
Yeah, so this gets really interesting. So the Y operator was told your assignment in the next 2 days was to track this person, whoever the operator is at the call sign CZE. So the Y operator had to know by the type of Morse code, they call it the fist, how fast they're sending, when do they pause for a few milliseconds. So they say, okay, this is Fritz, or this is Dietrich, the guy I'm trying to intercept. Now, Franz and Dietrich also moves across the band. Franz doesn't stay at 5,400. So there's certain parts of the day, they're told to move to a different frequency, like 4880. And if we don't know what that is, you don't, because there's no information beforehand. You have to, as a Y operator, you have to scan up and down the band and listen for the staccato of Dietrich or Franz and understand this is CZE by the operator. So you had to look for these people going up and down the bands. So, I mean, I have a whole new respect for Y operators after this. This is like crazy. It's crazy. Now, what's the point of all this? So the point of all this is called a message log, a Y station message log. The point is then, how do you get these messages to the code crackers? Well, conveniently, you set up an army of mostly women motorcycle riders, or if you were in another country, you had to have access to aircraft, the Air Force, to take these messages back to the UK. But ultimately, they have to get back to Bletchley Park because most of the heavy-duty decryption was done in Bletchley Park. Later in the war, they set up bomb bays and different machines outside of here. We'll go into that. So they were either sent by dispatch motorcycles, pneumatic tubes in some cases, and teletypewriters. Auto-type teletypers. So that occurred later in the war when they set up teletypes. But either way, you had to get these logs, these message logs, to where it can be cracked, where the messages can be cracked. So that meant, here's the schematic for that. So what you have, so for example, the RAF Y operator, if you look at the top to the left, is feeding, the name is feeding Hutch 6. The one next to RAFY Europe operators are also feeding HUT6 directly. So HUT6 looked like a magnet for a starting place with the, so you knew right away, the people doing the decryption, the leadership wasn't HUT6. They were doing all the, and this was done manually. In the beginning for several years, it's all done manually. And the way they do that, I'll show you in a little bit. I won't go in a lot of detail, but they have various HUTs set up to do. Alan Turing, I think he was in HUT 4, so he was doing some advanced work. And by the way, Alan Turing, his skill set was on the mathematics around decryption, and he had to rely on engineers and other HUTs. And for example, he had to rely on other people to understand how to make a computer. He knew what he wanted. He wanted a general purpose computer that could be done, and specialized the coding only, not the hardware and the coding, to crack codes. And so this was the Bletchley Park traffic routing. And so you see dedicated links also into various HUTs for the Luftwaffe, the Army, there's Air Force. DF means at the very top, there's two marked D/F. That's direction finding stations. So one of the things they keep track of is they also have to keep track of where the transmission's occurring. Is it occurring in the middle of Africa? Well, then there's a higher probability the code crackers could assign that to Rommel, for example. I mean, he was one of the leaders in Africa. So, but they'd like to know where the enemy is actually located. They're not going to tell you that in a message. And that's assuming you could decode the message. Sometimes they'll tell you where they are, but they don't. They tell you by the call sign, but the call sign doesn't tell you the Latin long where they are. So they have to actually find these people. So here again, so they had training for the female Y operators. There's teams that actually did the triangulation of the transmitter, the Nazi transmitter source, by using multiple receivers over a geographical dispersed area. And so you had very smart people doing signal strength measurements between the equipment, the receivers, and then at the same time, they calculate through mapping, they could calculate where the field troops are, specifically by the transmission, just by the transmitter signals. So there's teams of direction finding expert. That's where the DF comes from. I mean, this is crazy. The more I dug into this, it's just mind blowing. Let's see here. So this is a shot of manual decryption. So you had cryptologists studying the messages, and they had different tools. If you look closely, I don't know if I have a good shot of this. Okay, they had some manual tools that I don't see here, but there was a light table that they were looking for patterns manually. And here again, you had 75% are women. So it's a very labor-intensive process to do the manual decryption. And you're looking for patterns, repeating patterns, and it's mind-numbing work, basically. And it's not fun. You can see in this picture, you can see these huts are very dirty. They're kind of not only filthy, but they're the heating systems were slapped together, and they're not very good as far as temperature control. And there wasn't a lot of fun and games going on in here. These are very focused activities. Again, they're existential, trying to crack the codes, and you got to have people that work around the clock. The number of people had nervous breakdowns and sent to hospitals. But this is the number of possible combinations. And so decrypting messaging was the imitation game focuses, like I said, on Alan Turing. So his he designs basically the computer, what's called Colossus. I don't think I have a picture of Colossus. The bomb was a rotary type of system that matched up alphanumeric commands. So they'd mount letter by letter, they'd just go through and match sequences to see which would map from today's message onto other messages during the day. That would be a common key. So then the best data, what they learned is the best data for finding an Enigma key is a crib. What's a crib? So a crib it's kind of a cheat, because like I say, what you notice on messages, if they end things with Heil Hitler, or they start things with weather, that's a crib. So it's an English non-encrypted, English message that's consistent and encrypted, so they can pull out an encryption. They know what the output's supposed to look like. It's easier to figure out, much easier to figure out what the key is, and that was the secret of the whole program, by the way.
Joe?
Reject all. Yeah.
So I have a comment in the chat that actually goes back to the forum where they were, writing down the Morse code.
Yeah.
And this person, John, says QRX means standby. QTC means message. QRM is interference from another station or man-made source. And then QRN, interference from atmospheric naturally occurring noise.
Right. So these are international Q codes, and yes, that's exactly what they mean. So that's exactly right. I appreciate that. And so these bombays are very loud. They're very noisy, and they're enough to drive you crazy if you're in this room for 7 hours. They have multiple rooms. They had used to daisy chain these and run these in parallel. And but they're electromechanical, so they're not too cool. So one of Alan Turing's big contribution, or the biggest contribution, was to design an electronic version of this. I mean, this technically is an electromechanical system, but Colossus was the real computer that used vacuum tubes, for example. So the engineer on that was not Alan Turing. Alan Turing did the math and handed it to a Tommy Flower. Now, Tommy Flowers was a electrical engineer and who built the Colossus based on the work that Alan Turing did. So that was really the first computer applied to code cracking, was the Colossus. And that's why Alan Turing is a hero. But then, like I say, here's what's cool. So who are you going to call? Who are you going to call? If Alan Turing is in trouble, and by the way, his computer didn't work. It just didn't work because they designed it the way he did the math. It just didn't work. So his first go-to was Joan Clark. So Joan Clark was, in 1939, she achieved the double first in math. Cambridge did not admit women to full membership at the time, until the end of World War II. Due to her prowess in the math field, she attracted the attention of Gordon Welchman. So that was the other name that keeps popping up. So Gordon Welchman handpicked her to join the decoding, decrypting operations at Bletchley Park, a woman by the name of Joan Clark. And in the movie, that shows her to be his girlfriend, but I can't confirm that. I don't know, So this name came up. Gordon Welchman came up. So Gordon Welchman was the guy that made things happen, and he owned Hut 6, and he pioneered traffic analysis theory, and he personally was in touch with Winston Churchill, and Winston Churchill would reply to him with a stamp Churchill's famous stamp was called "Action This Day." You know, you talk about a guy that was big on action and not words. So whenever Gordon Welchman, he realized very quickly they're running out of people. They got to, for manual decryption, you need more people. So no one wanted to call or contact. You didn't call them at the time. No one wanted to run a message courier over to Winston Churchill and said, "Hey, we need another 1,000 people in Bletchley Park to crack these codes." So except Gordon Welchman, who had no problem doing that. So he contacted Churchill directly. And like I say, Churchill, in the movie Imitation Game, it didn't show, it showed Gordon Welchman, but didn't talk about him at all. But he was the mover and shaker here in not only Hut 6, but throughout this whole. I find he's really the brains of a lot of the operation. And he was the other person Alan would go to for help. So when Alan's computer design didn't work in practice and actually building it, Gordon Welchman solved the problem. So he went in and fixed his mistakes. And it was a very friendly relationship. It was a good relationship. Alan was very shy. This guy was all but shy. He was like get out in front of everybody, including Churchill. But he got action from Churchill. So if he wanted that 2,000 people, it moved into Bletchley Park, he immediately got the okay from Churchill. So he was the assistant director of mechanization for Bletchley Park. At that time, they didn't call it computerization, it was mechanization. Okay, so here's what's interesting also about this. So Gordon Welchman moved to the USA after they closed shop and World War II was over. They burned all the documents, which I can confirm that there was. I went into the Hadley Library to do research on RCA during this time period on the AR-88 specifically. And guess what I found at the Hadley Library? Nothing. It's all been destroyed. It's unbelievable. So they destroyed everything in sight. This guy left the UK. He taught MIT's, in 1948, he moved to the US. He taught MIT's first computer engineering course and built the first computer at MIT. And then he was also hired as a US communications consultant expert at MITRE Corporation. And he was consultant for battlefield communication consulting for MITRE. And I ran across this diagram above that shows communication that looks an awful like the internet. So he was brilliant in the sense that he understood what we needed to do to crack the codes. And I understand at the NSA currently uses his theory of network communication and statistically mapping. You know, what he came up with was, if I have a location and this phone number is in Yemen, for example, and I get repeated phone calls there to this Yemen number, which I know is a terrorist number, and it's from this number in the US, it gives you some idea of looking at the frequency of calls and the duration of calls by location. So he developed all the math theory around that, Gordon Welchman. Okay, let's see what I did. Okay, so we had the team of people there that had a lot of input from the Y operators. So one of the inputs in the Y operators I mentioned earlier is you can't allow drift on the receiver. You have to minimize the drift. So what ended up as RCA's specification was a drift spec of 0.001% of the local oscillator, which influences drift the most on an analog receiver. The other competitor was, at the time, the National HRO, is the one on the right. That was also a competitive and used not as frequently because the Y operators demanded lower drift, and the AR-88 won on that hands down. So the other thing is the UK got the AR-88s for free because it was part of the Lend-Lease deal, Roosevelt's agreement. Okay, so the HRO had much higher drift, so that was the bottom line on that. Some of John's restoration, great job, John. And some of the material I reused in the classroom, which I mean, the whole point of having the Sarnoff on campus, you know, I gave it to one of my classes, one of my labs, and I had him simulate using SPICE, which is a simulation language of the design of the AR-88, basically the RF section. And you know, that was very useful to use the Sarnoff for education, and we can leverage that, you know, in terms of the 1941 AR-88 that we received. Okay, any questions so far? I mean, pretty much what I've got here. Let me look at the
Yeah, do you, there are a few comments in the chat and one in the Q&A. In the Q&A, someone brought up that he's an ex-RCA person and interested in the subject, and he mentioned that he had written a bit about Joe Rochefort and the Japan Naval Code.
Yep.
And the bulk of the legwork there was done by 25 musicians from the sunken battleship California. So
yeah, I see it from Wesley. That's great, Wesley. Wish we could meet in person on this, because as far as the Japanese code, they called nicknamed their code Purple, and I have that book in my library. I haven't read it yet. It's been sitting there for a few years, but I believe that the legwork was done by 25 musicians, because my head immediately goes back to Hedy Lamarr. So for people that know who's Hedy Lamarr, they would think, geez, this was an actress years ago, Hedy Lamarr, which she was, a very famous actress in Hollywood. But one other thing about Hedy Lamarr, she has the first patent on spread spectrum communication. And it was her and her musician his name is on the patent, which the government immediately classified it and realized this has a lot of security implications for the United States. And there's books, if anybody wants to read up books on it, there's fantastic books. I mean, this is the kind of stuff you find out, is all the contribution talented women made on this, a lot more than given credit for. I mean, when you consider all interception had to go through a Y operator, and the Y operator had to understand and track Morse code. This is and the operator himself. This is crazy stuff. And then the Hedy Lamarr escaped Germany. She didn't like Hitler too much, so she left her husband and came to the U.S. and figured she'd play up her beauty and become an actress. And at the same time, she's working on patents on spread spectrum communication, which simply put is not staying on one frequency, but the one version of spread spectrum she worked on was hopping frequencies, different, spreading across multiple frequencies with what's called the pseudo-random code. But the this is crazy. So the 25 musicians obviously have a pretty good ear, what I know about musicians. And that's great, Wesley. We'll have to meet in person.
There are also a couple comments about books that might be useful. One person mentioned the Bletchley Girls by Dunlop and Code Girls by Liza Mundy. And I know that you also use quite a few resources for doing your research as well.
Let me talk about some of the books. Because like I say, you know, what's amazing is that these books are still coming out years and years later. They're still coming out because of all the great stuff the women and men were doing in World War II on this code cracking and interception. Let me open my camera, I can see that. So this book is particularly interesting because, again, this is the guy that led, he led the effort in HUT 6, and you see all those arrows going to him, which meant a lot of the intercepts went to Lord Welchman's team at HUT 6. So this book was the one that cost Gordon Welchman his security clearance. He was stripped of US security clearance, UK security clearance, because he published this book. They said, you talk too much about the technology and the, and this book was published in, republished in 2016. And I think the original publication is the late 70s or the early 80s was the first publication. But to think he lost everything because the government didn't like him talking about what he learned in 1941 through 45. It's crazy. The other books that I find interesting was, this talks a lot about the Y operators backing Bletchley. So this refers to the Y operators mostly. And they had field decryption, much smaller decryption work going on in the field. And again, mostly women decryptors and almost all interception women. So this is a good one too. I think this is the 2012 book. And then I have, this is the one I think you find the most fun. This is called Secret Empires. Again, this is a relatively new book. And this one is a riot because, let me just read something here out of chapter 2. Reporting for special duties. Many young women such as Pat Sinclair and Betty White also joined the Wrens. Now, who's the Wrens? The Wrens are the Women's Royal Naval Service. As fast as they could, almost flaunting the skill. So, in other words, these women that knew 25 words a minute were bragging, not to the enemy, but to each other and to the men. First, there was the patience required as they sat down at shortwave receivers and went through the process of trying to find the correct German frequency transmission being made from Europe in this case. And there was a laser beam focus required as the German operator began tapping out Morse and the young women armed with only pencils and special pads swiftly wrote out the letters as they heard. They're simultaneously translating from Morse to the ordinary alphabet. Not everybody had the skill. One veteran recalled in the early stages of war, a young officer in France frantically taking down an enemy transmission and having to write down the actual dots and dashes as he heard them. Not a great deal of use, as it could no easy merge, and the error rate is really high on that. So these all the services ended up giving women a choice of being conscripted in different, depending on their skill set. So if they were good puzzle solvers, and they spoke German and they knew Morse code, you go anywhere you want. And they immediately made him a captain, by the way. Once you passed the 25 words a minute school, you were made a captain in the British Army.
We have a couple other notes about books. We can definitely post a bibliography and reference list.
Sure.
We can put that up. We'll probably, what we'll do is we'll put it up on the Sarnoff website, and we'll link to it from where the video shows up on the Sarnoff YouTube channel. Someone else mentioned another book on the, I'm not sure how to pronounce it, Glenahirk Y Station, called Spies at Glenahirk by George Busby.
I don't have that. That's probably the only book I don't have.
Yeah, it says it identifies, includes biographies of people who work there in addition to voluntary interceptors. Mm-hmm. And then a little bit different note, someone mentioned an American codebreaker, Elizabeth Friedman, the woman who, and do you know about her?
Yeah, yeah, she's one of the most famous women in the US, of course. But she was the pioneer in the US on encryption. And Let's see what I had on her.
This person looks like there's a book on her called The Woman Who Smashed Codes by Jesson.
Yeah, I have that. Yeah, I have that book. Yeah, she was on the U.S. side, and again, there was a lot of work being run in parallel with the U.S. And it was one of the few. Friedman was one of the few women that was shared a lot of the Enigma stuff. So she got it early. Churchill had to sign off on anyone who got those messages, and he worked closely with her. And then we have more information on the Polish initial Polish work. So yeah, I'll publish a listing of the books, and I think if you're looking for a fun book that talks more about the training in the women and where they were sent, this is the best one, The Secret Listeners. And it's not very technical, but I mean, if you want a technical book, there's really not. There are books specifically dedicated to the Enigma machine, and there's hobbyists that have actually rebuilt, and there's a clone of the Enigma machine that you can buy. The original ones are very expensive. You know, one of them was one I think was stolen from the British Museum, and they did get it back. They're worth millions at this point. But then there's people that, like I say, that specialize in the technology. I'm interested in the receiver itself, because that's the RCA contribution, and again, that's falls under the whole idea of Unsung. There's no one that documented all the issues associated with the drift side. I think I'm the first to do the drift documentation. Okay, any other questions? Let's see.
I'm muted. Okay. There's also a question from Jim, and he asks, have you met any Knockholt intercept operators?
Personally, I'll tell you what's interesting. No, I have not met personally an intercept operator, but I've met personally one of the entry-level engineers that worked for the German Joint Chief of Staff in Berlin. He was a young guy at the time, and so he told me where I was working in Chicago, that the new employee's starting tomorrow. Would I take him to lunch? So he comes in, and here's this guy in his late 70s. This is years ago. His late 70s with a thick German accent. And I asked him over at lunch, hey, what did you do in World War II? A big smile on his face. He says, I worked at the German Joint Chief of Staff building as a mechanical engineer. Get this, a mechanical engineer in Berlin. So what's your next question going to be? Did you meet Adolf Hitler? And he just said, Hitler was the biggest nutcase. He says, we really hated this guy. He says, we did whatever it took to get rid of this guy. He says, he says, my boss's boss actually tried to kill him. And it was in fact, Stauffenberg was the key person that set the bomb at Volker, the story of Volker. And I met a guy, this is years ago, but I actually worked with him, mechanical engineer. He still was a mechanical engineer all these years. And but he was just telling me how much they hated Hitler, and that they would have killed him if they had the chance. They tried over 50 attempts to kill Hitler. I don't know if you knew that. But by the time people realized what a maniac he was, it was almost too late. They couldn't do anything about it. You spoke out against him, you were put in prison or killed. But that was the most interesting part about meeting Joseph Todd.
Cool. There's another question here, and this is from an anonymous attendee who asks, what is the relevance between Bletchley, Turing, Enigma, etc., and the references to MOSFET? Is it MOSFET pentode vacuum tubes that you keep displaying?
Yeah, it's a good question. What the AR88 uses vacuum tubes. And when we used LT Spice, my students weren't at a point where they're building new models. So I said, just substitute the tube with a MOSFET transistor. So it's just electrically, it's equivalent. It doesn't operate at the same voltages or bias and so forth, but the transfer functions are different, but they're close enough. They're high impedance and so forth. They have a lot of the characteristics of tubes. So I had my students build it with FETs because we had them in stock too. Anyway, we could duplicate some of the stuff we wanted to do. Let's see what other questions.
We also have a couple questions about Morse code. One person says, as a non-Morse coder, could you explain to me the concept of words per minute? 25 words per minute sounds like 150 characters per minute, which seems ridiculous.
That's a good question. Let me just do something real fast here. See if I have this working here. I was going to actually share with the audience what it sounds like. Okay, so can everybody hear this Morse code? Can you hear that, Margaret?
Oh yeah, now I can hear it. Yeah.
Okay. So this is a live Morse code intercept from Germany that I'm using. I won't go into details, but anyhow, so this is what Morse code sounds like. And this is very slow. This isn't 25 words a minute. This is very slow. So what the average, I'm going to have to actually look up what the average, I think it's 5 characters to comprise a word, average on average 5. And so 25 words a minute would be times 5 per character, the length of the character, in each character. Does that make sense?
Yeah, and Jonathan Allen added the usual definition of code speed is 5 characters per word. So
yes, yeah, I remember.
And there was a follow-up question to that too, is were there very many women that knew Morse code at 25 characters a minute, or 25 words per minute?
Words a minute, yeah.
Like, did they have trouble finding people who could
Yes, yeah, they
work
had
at that rate?
a lot of trouble. So they had to go through special military training. There was a special code interception education they had. I think it went for 3 or 4 months. I could check the references, but it was months, where a prospective person would get up to speed on up to 25 words a minute, or at least, I should say, at least 25 words a minute. So it is kind of crazy. Yeah, very fast. I can't do 25 words a minute. And so let's see here what the question is. Yeah, I agree with you, Anonymous. It's not crazy. It's what keeps our country and our country safe. Absolutely. And we have today in the U.S., of course, we have NSA, and they're a little bit mysterious to what they work on, and a little bit concerning what they work on today. But that's another question. Hedy Lamarr was considered an alien by the U.S. government. That's right. Never paid. She wasn't paid for the patent. It was just seized and stamped classified. That's right. Yeah, yeah. And we know of Hedy Lamarr as an actress today. We should know her as the inventor of spread spectrum communication. The British did not kill Hitler because he was so incompetent. I don't know, Al, I don't know what you mean by that. British did not kill him. Who was incompetent? Hitler kept moving. You know, Hitler was a hard target, and he would show up at odd times too. He was never one to come on time. I read somewhere where they were people that were trying to kill Hitler was off always on the timing, and bombs would go off and Hitler would be gone. He wouldn't be at the podium anymore. Killing Hitler may leave them with more. That's a good point, Wesley. Yeah. Well, somebody's asked. So nowadays you might use a FPGA, field programmable gate array, like Red Pitaya. You got it. Or I prefer the ADALM Pluto FPGA design kit for 150 bucks. LT Spice is useful, amazing. Yeah, I teach that all my classes involve circuits. LT Spice. We have a lot of the curriculums written around PSpice, but LT Spice is free and it's very useful. Paris. The U.S. paid people extra money if they could do Morse code in World War II. Oh, that's good. Al, that makes sense. You could see on the requirements that was a very valuable commodity, more valuable than knowing German. So, and you're right, they rely on Radio Society of Great Britain. I've been a member for years. I love it. It's great. I get the Radcom journal every few months. Every month. That's what they come out. Amateur license used to be 5. Yes, so amateur radio licensing used to be 5, 13, and 20 words per minute. There is no Morse code requirements to get an amateur radio license. I have all the way up to the highest, which is extra class. I own that, and I didn't have to pass any code test to get to extra class. So they've changed the requirements. They used to be 5, 13, and 20 words per minute. 25 isn't ridiculous. I agree, Robert. UK radio amateurs, a skilled Morse have recruited volunteers to listen from their homes. Oh, that's interesting. I didn't realize that they were. I think you're right. They talked about not getting enough people that had a ham radio background or amateur radio, so they were already skilled in Morse code, and
there was also a question about the AR-88. Someone asked, over what years was the AR-88 developed in Candom?
Yeah, AR-88 started in the late 30s, and it was literally started by Sarnoff, David Sarnoff, going to his chief engineer. I have his name down somewhere, but his chief engineer, and said, it's rumored to have that Sarnoff said, cost is no option. Whatever the thing costs, it's got to be stable. It's got to be used by the UK to crack the German, intercept the German messages. And I want you to design the best receiver you can design. So all this came from Sarnoff, but then as a true patriot, he never said anything about it after the war. He never bragged about having the interception receiver of choice. I mean, I ran across that just from looking at the photographs, like 10 to 1 more AR-88s than HROs. Yeah, Hedy Lamarr had to leave. Oh, that's a good point, Linda. She was Jewish. That's right. Yeah. Can you imagine a Jewish person married to a top Nazi logistics officer, military logistics officer, and she used to host Adolf Hitler in her home? Can you imagine that? I wonder why she ran away from home. That's crazy. And she was already famous as a movie star. I won't get into the details on that, but that's interesting, very interesting. Oh, Linda, you were a radio operator during the Korean War. That's fantastic. Oh, you listened to 5 alpha, 5-letter code groups for 8 hours a day. Man, how did you keep your sanity, Linda? I think, Linda, you can talk if you want to. Let her.
Should I?
Yeah.
Let me see if I can figure out how to unmute somebody here.
Robert is saying max Morse code was copied about 75 words per minute using a typewriter, not pencil. Yeah.
So Linda, I unmuted you.
Gotcha.
If you
okay, hang on. It's not Linda. It's Bob Melman. I'm using my wife's
okay.
computer. Yeah. It's mind numbing to be receiving code groups. We called them Paris code groups during the Korean War. For 8 hours a day, no words, just series of 5 letters. I remember one guy picking up his typewriter and throwing it out the window, for which he was court-martialed.
Oh my goodness! Oh my! Now, what location were you in when you were doing this?
I was down in Fort Gordon at the Southeast Signal School at that time.
Wow, that's great, Bob.
So anyway, I was in the English department at TCN too.
Talk louder.
Man, when we open up, you got to come in, Bob.
I will talk
In
about
fact, you'd be Margaret. He'd be great to give a talk. You know.
it. A lot of my classmates were Marine operators. They pulled them from the Merchant Marine. And
Well, the 5-letter code groups for 8 hours a day. All this. It turns out that the Russians figured out that we had cracked. That the British had cracked the code, probably through spies that they had in the U.S. And that's an interesting story too, by the way.
Yeah.
But they immediately switched everything over to the pad, you know, the unique index pad, rather than use any kind of machine equipment. So they went to manual. And there are Cuban spies that use paper. They don't use machines for encryption today. You can hear the 5-letter groups being called in voice today, and there's some spies going on around the world when you hear the 5-letter. And this time it's not Morse code; it's voice. Yeah, it's interesting.
And we have another guest who has a question, William Cowell. William, I'm gonna unmute you and you can ask your question.
Wait, leave it.
Let's see if that works. Okay, maybe we don't have William.
Well, I see his point. He said the receiver he used at Bletchley was a national HRO with the pluggable coil packs. Yeah. I tend to think the photographs I've seen is more HROs. I mean, more AR-88s than HROs. Because of the drift, like I said. I like the HRO. I have one in my museum. I should open a museum. I don't know. My wife thinks I should open a museum. Get rid of this stuff one way or the other. You know, AR-88 receivers 100 pounds. They're 100 pounds each. And in some of the Y site stations, the Y stations, they use multiple AR-88s for diversity. So turns out if you can RCA design these so you can stack certain versions of them, and so you can have 2 or 3 on, and they do a voting on the strongest signal gets to be outputted, and it could be different antennas like the MIMO structures today. So you can run different antennas and through different receivers, and then have the output being voted on through a circuit, and the loudest one gets through, the strongest one gets through. So that's why you see stacks of these things, and RCA tried to market that after the war, but I don't think they had it's just too much money to build these things.
There are a couple of interesting comments. One, there's a comment from one saying that there's an AR-88 on eBay for sale from Australia. But I don't know, shipping a 100-pound brick from Australia might be prohibitive.
Exactly. These are not minor league to ship. John Allen and I had. Luckily, he got a cart before we barely lifted it in a cart to get it into the Sarnoff Museum.
And there's also a question, what did HRO stand for?
That's a good question. I'd have to look that one up. And I have an HRO, so I don't know why I don't know the answer on that one. But it was National Actually, I've heard an obscene one. That's not it. Let's see. Let me look it up real fast. Okay. Yeah, I'll have to. I'll post that answer. I just don't know it off the top of my head.
Oh, here, someone said, John says HRL stood for hell of a rush order. I'm not making that up.
I have heard that, yeah. And William said he cut his teeth on a BC 348. I know those were, when I first got started, I worked with a BC 348. Are now referred to boat anchors. That's rude, Al. I mean, it's true. 100 pounds is really what they refer to as anything heavy. Old radios they referred to as boat anchors. Now they were supposed to destroy these at the end of the land lease deal. Yeah, if you're interested in this material, I also recommend the Verona communications encryption. That's when we realized the Russians were getting a lot of information from U.S. Senior people. I got my theories on that, but the Venona papers talks about the interception group set up in the U.S. for Russian spies to find out what's going on with the Russian spies. Yeah, I know they were our allies, but when I gave the beginning AR-88 speech on this a few years ago, I had a real historian tell me, "How dare I condemn the brutal killer in the Soviet Union?" You know, you know, he was just doing what he had to do. You know, Uncle Joe.
Let's see. Oh, and Jonathan, and Jonathan notes that the main reason the AR-88 weighs 100 pounds is that the chassis, cabinet, etc., are all made of steel because aluminum was being rationed at the time.
That's a good point, John. Yeah. And the other reason it's heavy too is there's a lot of shielding going on with the RF stages, as you pointed out before, Jonathan. You know, there's a lot of shielding, and one of the techniques of identifying surveillance receivers was looking at what they call the local oscillator leakage. And this would be in a super heterodyne, you have a local oscillator actually sending in a very minuscule amount of energy back through the antenna. So when you see a signal at an IF frequency, you can do some direction finding and locate the receiver. And they did that in a lot of submarine communication. They looked for submarines that way.
There's also a comment about Bletchley Park and about visiting Bletchley Park, like once we are all able to travel again in the hopefully near future. This person says they visited Bletchley Park and it was very interesting, and that the National Museum of Computing is also on that site.
Yeah, that'd be great. I've never been to Bletchley Park, but I have a lot of research around that. And what's too bad is a lot of the documents, like I said, never were burned or never showed up, and they were purged out of Sarnoff because of the probably because of the Secrecy Act. So I don't think David Sarnoff got enough credit either with that. I mean, I thought he was pretty much a leader when he came up with this interception direction that was phenomenal. Yeah, one-time pads, that's what it is. Quick line to dissolve the pads. Yeah. Yeah, they're number stations is the accurate description of what's being sent today is number stations. And you can hear them. Every so often you hear people, a voice, a woman's voice or mostly women's voice talking numbers. Groups of 5. Yeah, you can hear encrypted commuting 24/7. I think a lot of this is Cuban. It might be Russian. I don't know. I don't know the origin. Probably wherever there's. But anyhow, Stalin was, I don't think you can defend Stalin. I mean, he was a bad guy. And, but we had to win the war. So the strange bedfellows, you know. I know Britain had to win the war. This was, they were betting it all on Churchill too. Sigint by Peter Matthews, that's a great book. Sigint by Peter Matthews.
Oh, and the comment on that is written by a guy who went to Germany after World War II, and German cryptographers were put into decoding Russian communications for the Cold War.
Hmm. Yeah,
So-
by the way, it was never the encryption machine that caused them to crack it. It was always mistakes, errors. Like I say, signing things off with plain text. But there were in remote operators, if they were taking fire, guess what? You're not going to go through 3 people to send code. You know, you're going to send Morse code saying, I'm being fired on. I'm going to die in about 5 minutes, so I need help. And that's all clear text. So there were those kind of messages that we were being attacked and come save me. Here's my location. So we would see those too appear.
There's also a question, do you think current number stations are being decrypted?
No, that's a good question. What we mean by, you mean intercepted and decrypted by non-intended sleepers? I don't know. Probably a good good paper you can write. But I think the one-time pads are good. I mean, I haven't heard of any being compromised. And like I say, after Stalin figured out that they were intercepting all the German messages and reading them, not all, but he went back to a one-time pad.
So there are tons of questions and comments, and like this definitely, I wish we could have done this talk in person because it's definitely much easier to have this kind of conversation in person than trying to navigate written text. But we really appreciate that there are so many people really interested in this topic.
I think it's great. We could do it again. I'd like to have everybody typing Q&A and show up. It'd be fun. Well, my talk went, and Sarnoff on the AR88 went for about 4.5, 5 hours. It was over 4 hours. So there's a lot of interested people in this. So a lot of fun.
Yeah, and definitely easier to do that kind of back and forth in person than trying to type everything on a screen. So
yeah,
hopefully we'll be back to that soon.
Yeah, I'm in person at TCNJ this semester, so I'm teaching in person.
So any final thoughts? We can definitely post we'll post the video of the talk, and we can also post a bibliography or reading list. We've gotten lots of comments in the Q&A and in the chat of people suggesting books and documentaries, and we can add all of those to the list too.
Yeah, the Q&A, I'd like to get a copy. Yeah, make sure you copy that one.
Yeah.
Some good stuff in here, and people I'd like to contact after. You know, some of the security work that's going on right now is really interesting too, and how we're being compromised, and all kinds of stuff going on right now with China. But
yeah,
that's another talk for another time.
When we're in person, we can do that talk.
Yeah, the ACM is interested, and there's the IEEE groups that would be interested in some of these details too. I could always sponsor, and what's nice about IEEE being sponsoring from the Princeton chapters, they pay for all the food.
That's always good. So, well, I think we'll end the official broadcast. And like I said, we'll find a way to get as many of your recommendations about readings and videos and documentaries and things into the bibliography, and we'll share that with when we share the recording of the talk. And we will, I think what we'll have to do is plan for something in person once the Sarnoff reopens.
Excellent.
So,
I appreciate everybody.
yeah, and
This.
thank you so much, too. This was great. We were really happy to have it.
Very fun. It's good. It's good. It's two-way. I like the comments and the Q&As, and excellent. I appreciate everybody attending it.
Great. Thank you so much.